Okay. We have seen error correction, error detection mechanism and protocols, all the protocols we have seen. In our data link layer, there are two types of controls would be there. That means first link control and multiple access resolution. This is a multiple access resolution, which is uh, study of we are going to learn about how if the dedicated link, that means if you are using a cable, if you are using a cable with the one person, if one person is using that single cable, there is no issue, we do not have any issues. Every time you will send a message to the other person, he will get the message and he will return the you will get the acknowledgement. That is if it is dedicated one, we do not have any issues. But if you are sending multiple person, that means broadband or Airtel broadband or some broadband has given you a connection, the wide connection he has given to you. But give me a minute, I will make the chart here. Okay, so that I can view your issues if you are getting anything. Okay. When you are using broadband band at broadband, you are getting one single cable. You created your own network, that is the mini your home based network. There are multiple devices we are using. Each individual device or individual person, he can send anytime his email or message, data can transfer from one place to another place. That means throughout internet. Here there is a, it is not a dedicated link, it is a multiple access link. That means when you are sending multiple people are able to send the messages to different peoples and different times. There is no time that is you are sending some message, other people has to wait. There is not kind of like that. Everyone can send anytime, there is no rule software. But the cable is one only. How this cable is controlled, more than one people is sending. With the help of this multiple access resolution protocols, we are going to learn how if the non dedicated links, now how the non dedicated links are be used, and how your data link layer will control with the help of different protocols to soft processing of data transmission and error control and flow control. Okay, why multiple access? What is the need of actually we need multiple access? We know that. Why? What is the? It is a responsible for resolving the access to the shared media. That means when your cable is shared with the multiple member of students, and your one thing, uh, you are thinking that our college have 500 to 600 devices. Either yes or no? We are using college devices, all the things. These, wait a while, give me a minute. We are using 500 to 600 devices in our college, but we are not each and every device has a dedicated thing, a dedicated link to connect to internet. Is it like that? It won't be like that. Total college 600 devices, that means 600 to 800, maybe 600, more than that thing. More than 800,000 devices are there in our college, but we have only one shared media with broadband act. Broadband act media has, it has only one shared media. With the help of one cable, we are accessing thousands of devices. So whenever I am accessing I am using thousands of devices in our college with the same only single wire, single cable or single link. How it is not dedicated? Every person, not less than 100 people will send the messages and get the emails in the with the help of this shared channel. How this will work? There is no need of multiple access sublayer. If the channel is dedicated, we do not have any issues. If it is not dedicated, then we are going to have this multiple access control protocol should be there. Otherwise it would have the lots of issues. Error controls would be there and flow control would be there. That we are how we are going to resolve this there. We are going to see when nodes or stations are connected and use common link called multiple link. As like I have said, our college using 1,000 devices at a time. Our particular time we are using more than 1,000 devices also, but the broadcast link or the multi-point link is only one. Okay, the multi-point link or broadcast link, the ag broadband has given me us only one link, that is multi-point link or the broadband link. That only one link, common link is there. We are using that common link to post our messages, send messages, emails to the outside world, internet, through internet. That is called multi-point link or broadcast link. We need that particular thing. For these things, one only we have only one link. Multiple users are sending the messages and receiving the message. These messages are going through with the help of multiple access resolution protocols. How to access while a particular time, how to access this particular single link with the multiple user, we are going to use with the help of multiple access resolution protocols. Okay, now multiple access protocols are next categorized into random access, controlled access, channelization. Here, with the name of with the help of that names only, we come to know what are they: random access, controlled access, and channelization. Okay, random access. In this, we have Aloha, CSMA, CSMA CD, CSMA CA, and in control access, reservation, polling, token passing, and channelization, FDMA, TDMA, CDMA. Here, you see, random access means random name itself saying that we are not going to follow any rules, randomly we will send. In Aloha or CSMA or CSMA CD or CA. Randomly we are not going to manage any time management. We are not going to have any rules. Randomly, whenever you want to send, you will send. Okay, in random itself. For the sake of I'm explaining, you have to remember that. For the remembrance, I'm explaining this. Random means whenever you are sending, you are going to send that messages to the outside world. You are not following any rules here. Random access, controlled access. Here, controlled access itself, it is saying reservation means your particular time or particular tokens would be generated to each and every user. Controlled access itself, name itself saying that every user of that particular um, broadcast link or the shared link will have some tickets, either reservation point or reservation time or the polling thing, like that. With the how this polling and reservation we are going to see, but we are going to have an priority for each and every individual. For with the help of with the that priority only, we are going to send the messages, we are going to transfer the data, communication would be happen. Next, channelization. In this is the different from random and controlled access. Okay, in this channelization protocol, we are divide our cable shared media into parts: frequency division, multiple access; time division, multiple access; a code division, multiple access, CDM. Like this, We are going to divide our channel into subparts. In that subpart only we are going to forward the data from one place to another place. Okay, with the help of channelization, that means shared media is divided into and further divided into next parts, and we are going to forward the data. Okay, this is the clear thing: random access, control access, channelization. Okay, today we are going to see about random access protocols. Aloha. This method also called contentional method. There is no scheduled time for this, as we have discussed. There is no scheduled time for station to transmitter. That means whenever I'm sending station is nothing but nodes are your users mobile devices, whatever the nodes we are using for the particular station. There is no scheduled time to send the message or transmit the information. There is no scheduled time. Transmission is random among the station. Okay, whenever you want to transfer, you can transfer in the random access protocols, as we discussed. There is no rule to specify which station should send next. Here we do not specifying any rules for transmitting the data and the information. Stations compete with one another to access the medium. Okay, whenever you are having that is a public kind of thing, what you will do, you will stand on that particular thing and you have to compete one another. Then only you are going to get the chance. If you get the chance, you have to send the SMS message, and there is no guarantee that that will reach properly at the receiver. In this random acts, that we are how we are overcoming that thing also we are going to see in this protocols. Okay, stations compete with each other to access the medium. Okay, in random access, for each instance a station that has data to send, for everyone has to transmit that thing. Every node will have individually, there is the system is dedicated, our nodes or systems are dedicated to send the transmit the data. Yeah, we are using computers as anything in our college. We transmit the data. Communication is used for the data send only. It is used it uses a procedure defined by the protocols to make decision whether to send the data or not. Okay, we are not here in the random access. We are not going to do. Your protocol decides. Your protocol, random access protocols would be there in your data link layer. That protocol decides, make decision whether data has to send or not. Okay, we are not going to do, and your device not going to find the device is not going to choose the is not going to be the master to send the data or not. Your protocol device data link protocol will have the random access protocol. That protocol will decide whether you have to send the data or not in the shared medium. Okay, and there are that it depends of the states of medium. State of medium is nothing but your link, which your link you are using. If the link is free, anyone can send a message or data, you can transmit the data. But if the medium is busy, in that case you cannot send. If you are sending, if it while the medium is busy, your data will be go there, and that will be bottlenecked, or it will be stuck somewhere in that particular medium. Okay, in this, no station is supervisor. Your random access, there is no station to superior another station. No station is assigned to control over another. We have discussed already these things, but I am explaining once again what is the media access to. Anyhow, we haven't completed our random access protocols. So once again I am clarifying all these things. There may be chance of access conflicts collision. That means there may be while you are accessing the medium, one person is sending some data, transferring the data from one place to sender to receiver, one more node to another node. There may be a chance of having two or more devices at the same time has forward the particular thing, it will collide each other, and there may be a cross thing, there may be erroneous data will be transferred to right side. Okay, collision will be happened, and we don't know how to rectify that. That's the reason we are to avoid these things. There are four protocols are there: Aloha, CSMA, CDMA, CSMA, CD, and CSMS CA. Collision detection, collision avoid. Carrier sense multiple access. CSMA means carrier sense multiple access. Carrier sense multiple access collision detection. Carrier sense multiple access collision avoidance. And these are three are comes under collision sense, carrier sense multiple access only. Okay, Aloha is the different protocol from these three. Aloha. It was designed for wireless radio LAN, but it can be used to any shared medium. But it is designed. It is what was designed for wireless radio LAN, but you can use for any shared medium. There are two types of methods are in this Aloha: pure Aloha, slaughtered Aloha. How Aloha will work, we are going to see. It is a simple protocol. The idea is that each station send a frame whenever it has a frame to send. Okay, we have different frames. We already have discussed that every system or every node will have its data link layer or physical layer. Data link layer has the frames. It will divide the large information into small frames. Okay, each frame will have some data in that particular thing. Okay, payload, starting point and end point, that is flags. Okay, and it has this data to send. Sequence number also there. Only one channel to share. Here there is the possibility of collision when both the devices are sending one some packets to the through um, shared medium. In that time, what will happen? There may be a chance of having collision. How we are going to see? Here you see your pure Aloha. Pure Aloha. Whenever I have four stations: station one, station two, station three, and station four. Okay, over a period of time, that is the dotted lines are saying that there is a over period of time we are going to send in Aloha, pure Aloha. We are not following anything. Whenever I have frame, I will set. Okay, whenever I have frame, I will set. Okay, I have two frames in station one. Every station has the two frames. Okay, station one first in this particular in the first line you see station one has whenever it got the frames 1.1 and 1.2 it has set. Okay, meanwhile station 2 has also two frames 2.1 2.2. Okay, 3.1 3.2 3.4 4.2. Okay, now in this all are eight packets, yeah, eight frames are sending from station 1 2 3 4 to the destination otherwise, but they are all are using one shared medium they are using. Okay, but at the end only two packets, only two frames are reach is going to reach at the receiver. Okay, that is frame 1.1 and frame 3.2. Frame 1.1 and frame 3.2. Okay, all other frames are collide each other, it will be collapsed or it will go erroneously at the receiver end. Why? Frame is nothing but your frame is nothing but your bits. Okay, or that is for 50 bits or 40 bits variable size. If the other bits will come in the middle, okay, it will automatically collide. Okay, if the collision occurs, how come I know when we are going to start, where we are going to start? This station one is using different protocol, different things, and station two is going to send different things. But in my frame I have some starting from address to address. You are clear that in frame you are from address to address is there na sir. You can say if collision happens what will happen, but all from address to address everything is in our computer networks with bits and bytes only. Okay, all the bits only. This frame contains 50 bits, either zeros and 1 0 0 0 0 0 like that. In frame 2.0 also 1 0 0 0 0 0 0 like that only it would have. At the receiver end, if you collide a frame 1.1 1.2 and 2.1, it has merged, or it has merged with one each other. When how come I understand what is the sequence number? Either it is the station 1 sequence number or station 2 sequence number, or how I the receiver and understands that this is the frame is from 1.1 and this is from 1. There is a gap, collision happens, and I'm at the receiver and he can't understand properly. That's the reason this is collision is has the priority, and we are going to learn about this particular thing. Pure aloha relies on only acknowledgement. If the acknowledgement does not arrive after timeout period, station assumes that the frame has destroyed and resends the frame. Okay, we are depending, pure aloha is depending on acknowledgement. That means whenever I am sending one packet, if I get that particular acknowledgement for that particular packet, I am assuming that the packet received the receiver end properly. Otherwise, I am thinking that my packet is lost. I have to retransmit the package. Okay, or my frame. A collision involves two or more stations. Okay, here you can see, here in this collision there are four stations are collide one another. That means four stations data is collided here in this particular time. Okay, but in this particular time only two frames collided each other. Okay, there are two things. More than one station can collide each other. Okay, involves two or more stations. If the other all these stations try to resend their frames, the frames will collide again and again. It is going to collide. Okay, pure Aroha dictates that when timeout period passes, each station waits random amount of time before resending. Here we are going to, if we resend that thing, pure Aloha, what it will do? It will take some more time, random amount of time before resending the data, and it will wait back of time to resend. We will see the algorithm how your pure Aloha will work. First, k is equal to there is a one more thing, while k is equal to 0 number of attempts, I'm sending a packet is 1.1. You consider as a one packet is 1.1. I'm sending a packet. I will have a number k, that is a temporary variable, that is number of attempts. It is going to store number of attempts every time. Okay, first time I am number of attempts I will consider it as 0, and I will send the frame. Okay, and I will wait timeout period 2 into TP, that is TP is maximum propagation time. Till the maximum propagation time we are going to wait for that particular thing. If the acknowledgement receives, that is well and good. I do not have any issues. I will consider it as successfully transmission, and I will come out of that particular. If that particular acknowledgement I haven't received that acknowledgement in the particular maximum wait out time, time out time, in that case I will increase the k value, number of atoms k value. I'm going to increase. Okay, and how many times, if I am sending every time, I'm sending every time I'm sending the frames to the receiver end, but it is not going, it is failing. I have to have a fixation of that particular k max. That means number of attempts should not be 15 or 10. I fixed k max as normally 15 times. After 15 attempts, I am going to just abort the machine and I will restart the machine after some time. Okay, here I will check, I will increase the k value into increase k value plus 1, and I will check whether the k value is greater than k max or not. If it is greater than 15, I will just abort the mission. If it is not greater than 15, in that case I will go or wait for choose a random number of time that is r between 0 to 2 to the power of k minus 1. This is a random time we are going to choose. In that particular random time, i'm going to choose a number, some amount of time, and I will wait that particular random time and resend the frame to the outside. Okay, it this process will continues until either it is success or aborted that mission. Either you are succeeding or aborting. You are continuously rotating your data transmission from sender to receiver in pure aloha. Okay, these are the back of times, timeout period, and propagation delay. Time taking to send a frame between two most widely separated station. TP is the propagation delay. Propagation delay. What we have discussed now. Vulnerable time. This is the length of time in which there is a possibility of collision. Possibility of collision. Here you see between this B's end collision, A's beginning. Okay, A's end collides with C's beginning. Here, propagation vulnerable time is equal to 2 into TFR. Okay, okay. Now, timeout throughput. Aloha is z into 2 to the power of z into e to the power of 2 minus z. That is S max is 0.88184 when z is equal to 1 by 2. Slotted Aloha. We have seen pure Aloha. Now we are going to have slotted Aloha. In slotted Aloha, what we are going to see, we are taking the time into time slots. That means first in the pure Aloha, we have sent the messages or the information without any issues. We are sending the data whenever we want. But in case of slotted Aloha, our time is slotted slots. Time slot is divided into 1, 2, 3, as you seen in the image. Slot 1, slot 2, slot 3, slot 4, slot 5, slot 6. My time is, stations are 4 and the medium is 1, but time is slot. With the help of this slotted, what will happen when you want to send a message or frame in the particular time? Whenever the time slot starts, then only you can send. In the middle, here you see, in the middle, if you are going to send, it is not going to allow. Okay, here because of these vulnerable time is very high, we are generating slotted allow. That means if you are not allowing to start in the particular time, then it is not going to collide with another's. Okay, because of slotted aloha, we are able to send 1, 2, 3, 4. In the meanwhile, in the pure aloha, I can send only 2 frames without collision. But in slotted aloha, I am able to double the frames. Increased frames, we have double the frames we have sent without any collision to the receiver. Okay, because of slots. That means in the meanwhile, if you are going to send, I'm unable to send. If already time starts, if I am my time is meanwhile, that means in the middle, I cannot send any frames. Okay, because of with the help of this, we will increase the throughput in slotted allo. Okay, here you see vulnerable time is 2 into TFR. There is no rule to send any frame in pure Aloha. Slotted Aloha invented. Vulnerable time of the slotted Aloha is TFR. You will see one another. Wait a while. The throughput is half of the time with your pure Aloha to slotted Aloha. Give, give me a minute now. Okay, today's uh, in the next class we are going to today's class this much only. We are going to start CSMA CD. Okay, CSMA CD and collision detection. That we are not going to deeply study about that particular thing, carrier sense multiple access. These are the things, simple things, how this will work, and we will go forward. Why I am not going to deep, if I am going to deep, it will take more time to complete all these things. Okay, I'm activating your quiz. Are you here, ma? Can you hear me? Please complete your quiz. For the sake of attendance only, I have kept only 2 questions. You get your attendance and leave. The revision of second unit, we are stopping here. First unit, if you want first unit revision, I will complete by on Saturday or some other day. First unit we will revise. After that, we are going to start our regular sessions. For the sake of this particular thing, I have kept. Okay, is it okay, ma? I have activated your quiz. Please complete it by complete it in 10 minutes. After that, you can leave this session. If you have any doubts, if you have any doubts in this, please let me know.